have to say this one more time because I just realized for a second I didn't have my video. So the producer surplus, this is the function for the supply function. For any point, I still have the rectangle. And this green area is the producer surplus. What does that mean? Well, they get some extra value for selling. They're selling at, I don't know, 4 units at $10 per unit. Well, there is some extra value that we don't benefit from when they sell us particular number of units for a particular price. So they get something extra by selling anything to us at any price, at any number of units. And this is what they get extra. But how do I determine that area? Can anyone give us a suggestion? How to determine the producer surplus? I'm ready. One second. Yes.
Would it be the integral from 0 to a? And
from the supply function dx, but careful, because now I have the rectangle to subtract the area under. So it's AB minus.
Yeah, that's what I was.
Excellent. Yes, perfect. So it's the entire area of the rectangle from which I subtract what we know this means. The integral from 0 to a from s of s dx is nothing else but the area under the graph. That's how we started chapter 4, with area under graphs. So from this, subtracting the area underneath, I get the green area that is the producer surplus for any point.
So you keep AB outside the integral when you subtract it?
But AB is not in the integral.
Okay.
The integral always ends with dx. Anything, very good question. Thank you for pointing that out. I didn't say it. So the integral ends at dx. Anything else that follows is completely outside of it. You can write it like this and plus AB. Same thing. But I have to subtract the area under the graph this time. Here, from the area under the graph, I was subtracting the rectangle, the area of the rectangle. Here is the opposite. From the area of the rectangle, I subtract the area under to get this piece. Is this clear for everyone? That's all there is here. And now we are ready to look at problems. So let's start with just a simple application, and then we will look at the word problems. Okay, so I'm looking at these first, and then business applications, rent control, whatever. Okay, so let's start with 13. And the question is asking us, find the equilibrium point, find the consumer surplus at the equilibrium point, and the producer surplus at the equilibrium point. So, I don't know, let's start with 13. And the page is 480. Okay, so d of x equals x minus 4 everything squared. S of x is x squared plus 2x plus 8. How do we find the equilibrium point? I have the supply, S of x. I have the demand, D of x. How do I find the equilibrium point?
So them equal to each other.
Of course, thank you so much. Thank you. So x minus 4. So part A, the equilibrium point. Equilibrium point has to have x and y. Okay, so equals x squared plus 2x plus 8. I know that I have to expand this. There are three terms, so a binomial 2 terms squared is 3 terms. The first term squared minus 2 times the first times the second, plus the second term squared. Nice. I subtract negative 10x I subtract, so negative 16. So that's minus 10. And this was 8. Oh, I was hoping for some nice number, but I guess it doesn't have to be. So minus 8. So then x equals 8 over 10 or 4 over 5. I don't have any idea of what to expect, but let me just check one more time. I was hoping for a nicer number, but if it is what it is. First term squared minus 2 times the first times the second plus the second term squared, x squared plus 2x plus 8. Okay, so these two go away. I have negative 10 and I have negative 8. That's what it is. Okay, so the equilibrium point is 4/5, comma, and I have to plug it back in. So d of 4/5 is 4/5 minus 4, everything squared. What do I get here? 4 minus 20 over 5. So it's 16 over 5, and 16 over 5 squared. I'm just going to keep it as is. Okay, good. So that's our equilibrium point. B, the consumer surplus. The consumer surplus will be the integral from 0 to 4/5. It's kind of weird. That's why I was expecting something nicer. Do I have a mistake in here? It's kind of weird to have from 0 to 4/5. Does anyone see a mistake? Did I copy everything? It was x minus 4 squared, and then x squared plus 2x plus 8. Everything is okay, right? I'm moving 2x to this side. I have negative. I'm moving negative 16. Negative 16 plus 8 is negative 8. And
yeah, it's all right, unfortunately.
Yeah, okay. It's just an ugly number. Okay, so this is consumer surplus, and this is from the demand. So x minus 4, everything squared dx minus, remember, so this is the equilibrium point. This is the 4/5, and this is the 16/5. How much is that? 16. So 16 divided by 5, and if I square that, 10.24. Okay, so 10.24, and this is 0.8. I have to multiply them, right? Because I need the area of this rectangle. So 0.8 times 10.24. 8.192. So the consumer surplus is the integral from 0 to the x of the equilibrium point from the demand function, which is this, minus the area of the rectangle, this times this. We're going to calculate in a moment. What about part C? How do I write the producer surplus? Can anyone give us an idea of how to write the consumer surplus?
Uh, 8.192 minus the integral of
Same, yes,
yeah,
but not from this function,
from the supply function.
from the supply function. And that's it. Of course, we have to calculate all this and see the amount of dollars for consumer surplus and producer surplus, but this is all we need to remember. So now let's go back to part B and determine the consumer surplus. I will expand this as, again, x squared minus 8x plus 16 dx. And then I have x to the third over 3 minus 8 x squared over 2 plus 16x. Oh! I'm leaving numbers behind. Don't let me do that. from 0 to 4/5 minus 8.192. And I have to plug in 4/5, and when I plug in 0, everything is 0, so I don't need to. I'm going to use the calculator just to speed this up. So we're going to go to math and then 9, and we have from 0 to 0.8, and from x minus 4 squared. Don't forget at the end, minus 8.192. The other one will be 8.192 minus math 9 from 0 to 0.8. From the other function, where is it? Okay, x squared plus 2x plus 2x plus 8. The x, don't forget the x. Okay, so the consumer surplus is $2.22, and the producer surplus is $0.98. That's all there is to it. Now let's look at a word problem. Okay, so something like, let's say 25, price floor. Okay, we'll see what that means. Suppose the demand for bicycles in Ocean Shores is such and such, and the supply is such and such, where X is in thousands of bicycles. D of X and S of X are in dollars per bicycle. Find the equilibrium point, find the consumer surplus. Suppose a minimum price of 200 per bicycle is imposed. Find the point for that 200. Find the new consumer surplus and the new producer, and find the deadweight loss, and so on and so forth, if they sell only 200. Okay, so we'll see. We hope to be able to finish this problem. If not, this is the entire section. We just have to practice. So let's look at 25. We are given the demand. Maybe these numbers are nicer, but I doubt. We'll see. And the supply is given by S of X, 135 plus 0.5x, where X is in thousands, X thousands. And of course, these are in dollars per unit. Okay, find the equilibrium point. You already told me for the equilibrium point, we need to set those two equal to each other. So 275 minus 1.25x equals 135 plus 0.5x. Okay, so when I move this here, I get 140, I think. Correct my numbers at all times. When I put this here is 1.3. Yeah, it couldn't be worse, right? So
Isn't that second one? Oh, sorry, I was doing it wrong. Never mind.
no, maybe I did. Maybe let me check. I always like to go back, and it's okay. Oh yeah. This is 7.5. Okay. So 1.75 on this side and 140. So X equals 140 over 1.75. 140, 1.75. Okay, much nicer. Thank you. Units, but it's 80,000 actually. Okay. So we found that the equilibrium point has 80,000, comma, 275 minus 275 minus 1.25 times 80,000. I still have to use 80, however. 175. So the ordered pair will be 80, comma 175. But we have to keep it, and we have to remember that it's 80,000. Okay. So 80. Oh, I should get rid of that as well. Okay, so we found the equilibrium point, 80, comma 175. Okay. Part B. They want us in part B to determine the consumer surplus and producer surplus at the equilibrium point. So let's write the formulas. Consumer surplus and producer surplus. Can anyone help?
I can do the consumer one.
Yes, so let me just also multiply 80 by 175. 14,000. Good. To have everything ready for you.
So it's 275 minus 125 x d of x.
So it's the integral
Oh, yeah, sorry.
from 0 to 80. Correct? From 275 minus 1.25x dx minus that 14,000. That's what I got. Excellent. Now, what about the producer surplus?
The integral of 0 to 80, 135 plus 0.5x dx.
Do you want me to show any of these by hand? Or we can calculate them directly? Don't be shy. If you want me to show it by hand, I will.
On an exam, would we have to show everything by hand?
At least one of these I would like to see by hand, just to make sure. So just tell me which one, and we'll do that particular one.
Well, let's do consumer surplus.
Very good. So consumer surplus will be 275x minus 1.25x squared over 2 from 0 to 80 minus 14,000. And all I have to do now is just plug in, because when I plug in 0, everything is 0. I only have to show this, like this, as you see it right here. And then you can put the answer. I'm fine. But if this is 5, then you have to write minus, so on and so forth. So we can put it in as 275, because I have the numbers are not that difficult to work with, minus 1.25 times 6,400, which is, which is 80 squared. And don't forget to divide by 2, and minus 14,000, and enter. So that is 4,000. $275 times 80, 125, 80 squared divided by 2, minus 14,000. Okay, so now let's look at part. I know I'm running out of time. I know that. I have 5 minutes. Good. I'll stop in 5 minutes. 5. Suppose a minimum price of 200 per bicycle is imposed. So find a point. So when x equals 200. The price, let's take a look. So this was the price per unit. So that is price per unit. X X is the number of units. So the price per unit, let's suppose they say is 200 per bicycle. Find a point X, they say XFPF. Okay, so the price is 200. So all we have to determine is the number of units. How do we determine the number of units? Suppose a minimum price of 200 per bicycle is imposed. So the consumer, that surplus, I'm sorry, the supply is this, the producer, demand is this, and this price could be here, right? Could be here 200. So that's the minimum price. Or it could be here, 200. Either for this or for this. So what do they call F? They don't specify what this F is. Because E, it's called the price floor. Okay, is the price floor. Okay, the minimum price, which is the product may be sold. Okay. Okay, so that is only for the demand function. Okay, so here we have to find the demand function, or set the demand function equal to 200. And from the demand function, we have 275 minus 1.25x equals 200. 275 minus 1.25x equals 200. So I move 200 here, subtracting. So I have 75, and I move this to the other side, 1.25x. So x will be 75 over 1.25. So let's see the number of units in thousands. 75 divided by 1.25. I got 60. So x equals 60 units. But it's thousands. Okay. Find the new consumer surplus and new producer surplus. Okay, fine. So this time, they're basically giving us a new point. Not the equilibrium point, but this new point with 60 to 100. And they want us to repeat both steps. The consumer surplus now will be the integral from 0 to 60 of 275 minus 1.25x dx, but minus 6 times 2, 12, and 3 zeros. The producer surplus will be, if a problem like this, you don't have to do it twice. If you did it once, I'm fine. So 12,000 minus the integral from 0 to 60 from the other function, which is 135 plus 0.5x dx. So this is a new point. It's not the equilibrium point. It's not the point where everybody is happy. 80, 175 is a new point. I will stop here because I think the time is up and I don't want to, we can continue if you'd like, but you don't have to stay. So we can continue this problem on Monday. I just want to find these two. I'm just going to put them directly in the calculator so we have them here because we know how to calculate this now. Okay, so we have math and number 9, and we have from 0 to 60. I just want to finish just this calculation, put it in, and you know what I'm doing. 275 minus 1.25 x, and of course dx, and I have to subtract 12,000. And now 12,000 minus and math and 9, and I have from 0 to 60, and this is from the other function, which is 135 minus, I'm sorry, plus 0.5x, and then dx, and press enter. Good. So the first one is 2250, and the last one is 3000. Very good.